thank you. Thank you for coming to what could be the worst possible session time in PDC, the final day during lunch. I appreciate you guys foregoing food. I decided to eat anyway, so I hope you guys have food. Please do not throw the leftover food up on stage. It really distracts us. As somebody mentioned, apparently we're going to have some geocoding going on today.
Yeah.
Yeah, it's going to be...
Sorry, I'm eating.
Yeah, sorry. Not my joke. It's... great. This talk was not going to happen 6 months ago. In fact, this feature, this entire language that we're talking about today, was not even a feature that we were planning on building for this release. Steve Luco and Gio, Doug Walter, a bunch of people on our team have been working on some transformation technology for about, 5 years? And in the meantime, they're off doing their thing, building this great runtime, and a couple of us on the team start building this wacky new thing called M and start trying to capture data and write it down and allow it to be put into a repository. And at some point, we decided that we needed to, we wanted a compiler, we wanted to build something, and we found this great body of code, and we started implementing our compiler on top of their great work. And we thought it was an interesting way to build a compiler, an interesting way to build a language, but not necessarily something that was really part of the product. It was more of an implementation detail. And then we started talking to customers about what we were doing with modeling and with all of this. And an interesting pattern started to emerge. All of them wanted, or many of them wanted, to control the textual representation of their data. They didn't want to necessarily always use a general purpose language for writing down their data and schemas and things. They wanted to have a tuned version for their domain. And today, what people do for that is they write down XML. XML right now is where tons and tons of, we see a lot of people building these domain-specific languages by writing some XML and then just kind of tolerating the fact that there are these angle brackets in the way, there's all this ceremony, all of this limitations of it, and they just live with it because writing parsers, writing languages is just too hard. And so as we started talking to people, we realized that the way we built our compiler is exactly what customers were asking for in building on top of the Oslo platform. And so we started talking to them about what we were building, and ever since then, we've seen this textual DSL space become more and more prevalent in our discussions about how to do modeling. And so this talk really came out of direct feedback from customers, from people who said they wanted this type of feature, they wanted to be able to write languages much more simply. And so it's, I think the word that was used the other day was it's nascent technology. Nascent. It's still churning. Nascent? Nascent. Nascent. Great. So I'm Chris Anderson. I'm an engineer on the team. This is Gio. Gio knows everything about parsers and everything about languages.
Everything, Chris.
Your mic isn't working.
Oh, mic? Oh, there you go.
There you go.
I gotta pull my shirt up. Go ahead.
Better. You were a little, yeah.
Hanging low.
And my job on the team is to actually know nothing about these things. We want to make it that it's so easy to build languages that even I can do it. And so that's what we're trying to build. Excellent. So, M. M is a family of languages. And we have lots of children in our family. We have mgraph for writing down data. We have mschema for schematizing that data and capturing it. But we don't care about them at all for the purpose of this talk. And we don't care about the rest of Oslo. We don't care about the repository and the tool. We don't care about any of that stuff. This talk, all we care about is mgrammar.
Of course we care.
Well, we care. Well, for the next 60 seconds, we're going to pretend like we don't care. 60 minutes. It would be a really short talk. So we're going to focus on mgrammar, which is this way of taking text, turning it into structured data using your format. So let's get a little more concrete about what this means. If you look at the bottom, we see an example here of writing down the structure of a point, an X and a Y location using what we call mgraph notation. So it's a label-directed graph at the bottom. Simple data structure we think can capture relational data, hierarchical data, object-oriented data very easily. Above that, we have a little snippet of mgrammar, which defines a DSL over that, the ability to write X comma Y instead of having to write all of the stuff you see at the bottom. And at the next layer up, we see a schema for that point has an X and a Y, and now we can structure that. And across this, we've now built a domain model and a language and an instance of that. So this is, when we talk about building domain models and having these multiple layers, this is kind of what we mean by that. We think people are going to build lots more of these over time. Great. I'm tired of PowerPoint. I want to go build something that will parse this language. We have a language here. This is my language. This is my micro format. I want to build a contacts language. I want to be able to turn this into structured data. I don't want to write some angle brackets or curly braces or any of that stuff. I want people to be able to write this down, and I want to be able to interpret it on my system. And so what we're going to do for the next,
You're crazy, Chris. Crazy.
XML would be so much better. What we're going to do for the next, most of the time for the rest of this is we're going to implement a grammar for this and play around with it and do a bunch of fun stuff.
Great.
So we're going to use a tool called IntelliPad, which ships as part of the Oslo SDK. It's built on top of the VS editor, and all the features you see here can be done inside of Visual Studio in Dev 10 timeframe. But we're just using a little host shell to play around with for now so that we can actually do it. We don't have Dev 10. What you're going to see is on the left-hand side of the screen. I think so. Yeah. Left-hand side of the screen, you're going to see an instance document. This is where we're going to write contact, geo, and all that stuff. In the middle, we're going to define our grammar. mGrammar is a functional transformation language. It allows you to, transform things. And so that's what the triangle means. It's transform. And on the right, you're going to see mgraph, the output. And this is going to be the transformed data projected out there. And at the bottom, if we accidentally type an error, you'll see errors at the bottom, and we'll be able to navigate through those.
Or intentionally create.
Or intentionally. Sometimes we do, yes. Every error we do is intentional, actually. Great.
We're hoping.
We're done with PowerPoint. Please, let's go back to a tool.
Yes.
Wonderful. Fabulous.
Great. So, Chris, I have the Oslo SDK installed on my machine that you all can have access to on the internet. I'm going to come here to the Oslo SDK and open up tools. Now, as you said, this is nascent technology, our favorite word of the conference. Since this came in hot, we are in samples-enabled mode. But one of the benefits of that, this IntelliPad grammar mode you're going to see, but one of the benefits of that is you're actually going to be able to get to the source of it, and you're actually going to see how it all works. So let's start that up. Let's maximize. And let's zoom for everybody so you can see what's going on. How about 1.5, Chris?
1.5 sounds great. Okay. Sounds excellent. We're going to go into magical Control-Shift-T mode, which lets us put it into this three-pane mode, where we're going to see the instance document on the left, the grammar in the middle, and the output on the right. Wonderful. Now, before we build our contact language, that powerful way of writing down people, I have a legal obligation I must do first.
A legal obligation?
A legal obligation. When I became a developer, I was told, if you ever show a language, you are legally obligated to show Hello World first. You cannot jump right into some scenario focus like parsing customers. So Geo, please, let's write Hello World. So we're going to write a module. This is the unit of container, of encapsulation, boundary. We're going to define a language, and then we're going to define syntax main. Just like in C#, where you have a main function that represents the start of your program, we have a main syntax which defines the start of our grammar. This syntax, this language, supports exactly one instance document. Please type that instance document.
We have an error.
We already have an error? How can we already have an error?
We have an error.
Oh, we have an error. Yes. The blank document is not a valid instance document in our Hello World language. It only supports Hello World.
We got Hello World done.
That's our first grammar. However, it is a silly grammar. It doesn't let us do a whole lot.
Just Hello World.
Just Hello World. It is a single purpose. It's a very domain-specific language. So let's go back to our context. So in grammars, we have two types of things. We have a notion of token, which is basically the words of your language. It lets you split apart these strings of characters and say, these are the words that make up my language. And we have syntax, which defines the sentences of your language, which is how these words string together to have meaning. So Geo's going to define a new token. And since we're talking about contacts, we're going to define it as alias. At Microsoft, you're only uniquely identified by your email address, which we call your alias. You cannot speak to people using their given names. And so I am Chris Ann and GODL. We cannot say Giovanni. So we're going to define an alias as being any character in the capital range or in the lowercase range. So the dot operator is the range operator, and it goes through and it says anything starting with the Unicode code point A to the Unicode code point Z is valid, and it, for both upper and lower, and then around that we put a parentheses, and we're going to say plus. We're going to use a clean operator, so please keep the room clean. We're going to put plus, which is a, nobody got that. I'm so sad. So sad. Great. So we define that as a plus, and now we can define that range. So please, let's take an alias. And now we'll notice that we have an error at the bottom, which is hello world does not conform to our grammar. And now we can say GODL. And we have our variable. We can now type, can you type other names? It will take any individual name.
It will.
Wow, this is a powerful language. We're getting there. So, next part.
Yes.
We noticed from the text we had before that what we wanted to parse was contact colon alias dash phone number. That's what we're trying to get to. Contact colon alias dash phone number. So we're going to put in a literal, which becomes a token, becomes a word in our language. You can define the words in line. So we define that contact colon and followed by an alias. And now we need to add the contact over to our instance. Beautiful. Geo, I've heard that white space sensitive languages are a bad thing. So I noticed when we want people to be able to put white space in our language.
Sometimes they want them.
Sometimes. Now at this point we have two options about how we model white space, because we really want a space between the colon and the next word. And we can either explicitly model white space everywhere we want. If we were building a white space sensitive language, then that would be a fine way to go. In this case, I want it to be very flexible. I want you to be able to put white space anywhere, type anything you want. And so what we want to do is we want to just allow that all over the place. So Geo's going to use a feature called interleave, which allows you to define an arbitrary stream of additional tokens that are just going to be thrown away. So please call this tokens I hate. I hate these tokens.
What kind of tokens do you want, Chris?
These words are in my language like ums and ers and huh. And you want that language? Just those languages? Just omit that? Or just have that? Great. So we're going to say space, carriage return line feed, say semicolon, and now we see that we've got it's parsing correctly. Geo, if you would please, I want a colon before. I want a space before the colon. Ooh, we have a problem. That interleave, I told you it was the parts of it was words, it was tokens you want to drop on the floor. When we defined contact colon in quotes, we defined a single token. Our language, the M grammar, knows nothing about your domain, your text format, so it doesn't know that colon is any different than the T at the end of the word. You don't want to be able to put an or in the middle of that. And so what we need to do is split this into two tokens, two distinct words, which can now have white space between them. So if you put the quotes, great, lovely. We have parsing.
And by the way, Chris, we do take single quotes or double quotes for anything. That's a great feature from XML attributes.
Yes.
So you can do whichever one you want, or whichever one you...
Which one are you using? Are you using single or double?
I have both.
You have both? Excellent. Yeah. Wonderful. Fabulous. However, we have a problem. We know that we want to build structured data. We know that we want to have data on the output. We want to get a M graph on the outside. And what we get on the right now over there is we have a lot of syntax from our surface language showing up in our output.
It's awful.
It's awful. It's horrible. No one could understand that thing on the right. No. So let's put an arrow, the arrow operator, which allows us to control the shape of the data. So we're going to put arrow. Let's give it some a label. We're going to say that it's called contact. We're going to put an open curly. And what we're going to do then is we're going to include the alias, give it a name, alias. And then what we now need to do is somehow reference the alias that the user typed in, because we want to be able to suck that out and put it in the middle of the graph. So we're going to give a variable binding. We're going to call it a colon, and then we're going to reference it down below. Ooh. It's okay. You can clap. It's okay. It's so fun. It's great to have people in the front really helping.
Chris, we create a separate definition for contact. Should
yes.
we be better programmers?
So we can have more than one function. Just like in code, you can have more than one function. You do not have to create everything in one long string. So what we're going to do is we're going to refactor this a little bit. We're going to create a new syntax, which is a new rule, and we're going to reference it from main. So these are, you can have any number of them. Great. And now we want to do phone number, right?
Sure.
Great.
That slide did have a phone number on it.
It did have a phone number. We want to parse that. Now, the phone number is not an alias. It's not a word we already have in our language. We need to now define phone number to our language. So phone numbers consist of digits. We need to have numbers. So we're going to define a digit as being anything from 0 to 9. We could make it be hex, but that would be just silly.
I think the audience might like that.
Let's not vary from the script
Okay,
here.
sorry.
Let's stay on target. The bits are nascent, as we said.
Yes.
So great, we're going to define phone number. Phone number is a set of 3 digits followed by a dash, followed by a set of 3 digits, followed by a dash, followed by 4 digits. At least here it is. And we could create other forms of numbers if we wanted to parse all sorts of different things, but this is the general shape we want to do. Now, if you remember, now we've defined a new word. You cannot put white space between here. You cannot have arbitrary space or anything because we've made this be a single token.
But we could add white space.
We could if we wanted. We could add white space optionally, but we're not going to. Again, we're on target.
Yes, sorry.
So now we want to support phone numbers in our contact.
Yes.
So if you noticed it before, when we said that we took A through Z, either capital or lowercase, we put a pipe, a vertical bar, and that's the OR operator, which allows us to do multiple options, multiple forms. So we're going to add a contact form that supports the phone number. Because we want to support people without phones, because not everybody has a phone, so, you know. Yes. Great, and so we're going to say that you can take a phone number. Fabulous. I can see the typing now. I can see the structure. And we have a valid document, because we optionally support the phone number. So, Gio, let's add a number. Excellent. Your 425 number. Your secret Batcave number.
Yes.
Only we know.
Microsoft friends.
Don't tell me. Great. So we're parsing it. We've got a shape. We've got a couple different kinds of words in our language. We've got a nice syntax.
Yeah.
The next thing we want to do?
Well, we're done with this part, Chris.
We are done with this part.
Yes.
The next thing we want to do is look at slides again, because we've had so
Well,
much fun.
we parsed what you said to parse.
We've parsed what you said to parse. You are absolutely correct. We have defined our language. It's excellent. So I want to review what happened. This was our input document. We wanted to tokenize it. Tokenizing it basically defines the words of your language. It comes up with these little structured pieces, and even those interleave tokens end up being tokens in the grammar. We then need to parse this. We need to create the syntax tree. This is the sentences of the document. We had an example. But we had interleave. Interleave sucked up some of those tokens,
Quick.
made it fall on the floor. We threw them away. They're gone. We then shaped the data by using the arrow on the other side. We created a structure. It's the first time I've had a build slide. It's terrifying. We created the structure.
New PowerPoint ventures for you.
It's terrible. It's bizarre. And what we did here is we linked up into our structured data portions that came out of that graph. And so we were able to suck up the tokens and give the text in this structure. Fabulous. Wonderful. So, enough PowerPoint? Everybody understand? Everybody following along? We're all good? Everyone's awake? 3 people are awake. Great. So, we're going to do some more advanced topics. I was told that we need to show every possible thing. Go
Yes.
deep, show it all. It's wonderful. Great. First thing we want to show is we love structured data. We love structured data so much, our grammar is structured data, and we want to be able to annotate. No, we want.
No numbers. Chris, I have more than one number.
I got to remember the order of these things. I'm a horrible person. Great. Multiple phone numbers. So what we want to do is add the ability to have more than one phone number. We want to be able to parse something that's not just a single number, because Gio has lots of friends, and each of them gets a distinct number, so he can decide who's...
I have a Fave 15.
So what we're going to do is we're going to define a list.
Your jokes are better than mine.
Now, if you've done a lot of functional programming, which I haven't, there's this odd behavior of you can't mutate data. You can only create new data. So if you want to create a list of things, you define it somewhat recursively by saying, I never have a long list. What I have is something that is a list followed by a single item or a single item. And then you recurse and you recurse and you recurse, and that ends up building up this nice list. And so what Gio's done is he's typed the version of that here, which you can see at the top. It says I can take one phone number, or I can take a list of phone numbers followed by a number. So I think we should be able to parse now.
Well, we should use it.
We should use it. That's good. And then add a couple numbers. I think you have 425. You have 206.
I have a local number, too.
You have a local number for all your friends down here?
Yeah.
Do you have a New York number or anything?
I do.
You do?
Okay.
Great. Gio is
Oh,
a popular
sorry.
guy. Now, look at the tree on the right. The tree on the right is a bizarre shape. It is not normal. we wanted this nice list, but because of this recursive nature of the language, we ended up creating all these nested things. So what we want to do is we want to unroll that. We want to come up with a simple, flat list of numbers so that it's much easier to find. So you have this operator called values of, which values of just says, I'm going to eval the list. I'm going to for each the list and return it up to the parent. It's splice, right?
Splice.
That's the fancy word for it?
I've been teaching you all week, and
You've been trying it. Every time I've said this, you've told me to use that word. So there we go. We got a flat list now. Very shaped. It's a beautiful thing. So, wonderful. Now, I love this language, but it really only supports one of us.
Yes.
I want to capture my data as well.
Yes.
So what we want to do is we want to create another list. We want to create a list for our contacts so that we can have more contacts. But
You want me to write that whole thing again?
I don't want to write that whole thing again.
Oh, okay.
We've learned from our programming, from our writing code, that it's nice to have not only functions, which is kind of how you should think about syntax, but functions with arguments.
Oh, my.
Ooh. So please add an argument to this thing. We're going to rename it to comma list. We're going to give it, the argument we're going to give it is the type of element you want that you want in your list. So depending on how you want to think, you can say, oh, this is kind of like generics. This is kind of like an argument and a method. It's depending on how you think about generics. And so now we're going to be able to change this. We're going to say that we take a comma list of phone number, and we should continue to be able to parse.
Yep.
Wonderful.
Great.
And now up top, in our main, we want to take a comma list of contacts.
And let's make it nice and pretty. You see all that.
Your data should always be pretty.
And
Great.
now let's go ahead and say contact Chris Handy. There we go.
Beautiful. So we have our list. We've created a parameterized rule.
Yes.
Now we're ready to go to the I have data and I want to annotate it.
Yes.
Yes, thank you.
Yes.
So I have data, and we love data so much. Oh, wait, I did that part.
We want to annotate it.
We do. What we're going to do is we want to put an attribute. We have attributes which are annotations on the grammar. Those attributes, some of them are consumed by our parser machinery. Some of them are consumed by other runtimes. So what we're going to do is we're going to add one that the parser knows about, which is at curly, which is, we're now going to do an mgraph here, case-sensitive, false.
Case sensitivity, Chris.
We hate case-sensitive languages. Turns out one of the things I hate about XML is that if I mistype, if I hit the shift key at the wrong time, the whole thing falls apart. So we're going to make this language support any syntax. And so Geo's going in, and we're yelling sometimes, we're going quiet sometimes, but it all gets parsed and creates the same structured data. Fabulous. Now, we have one other thing we want to be able to do.
Yes.
We showed, that's an example of a parser consumed attribute, but we also want to have other things. We keep the grammar alive all the way until runtime, and so we can do things like language services based upon the grammar. So, Geo, let's add a token for contact. And what we're going to do is we want the keyword for token to, or for contact to be colorized as a keyword in our language. So we're going to add is, if Geo can type.
I'm sorry.
Faster, faster.
Is everyone in this room tired too from the long week? Yes.
It's been a long week. They're too tired to clap that they're tired.
They're too
That's
tired
a
to
sad
clap
state
they're
of affairs. So we're going to add a keyword. Wait, don't. Oh, you already hit it. Oh, you missed the build-up. So you get colorization just based on the grammar. Fabulous. Excellent. And now, comment? Oh, yes.
We got time, Chris.
We got time. We got plenty of time. What time is it? What if your name is Contact? Ooh, let's see what happens. What if your name is Contact? Oh!
We colored it, but we actually parsed it correctly.
We parsed it, but we colored it.
But we did parse it correctly.
But this feature, we actually have been thinking about this feature. It's syntax. Right now we're doing token-based highlighting. And what we can be doing is doing syntax-based highlighting. And that would actually fix this problem, because we know that it's not the keyword. We know that it's not that version.
And now you might want to say you wouldn't allow it to be a contact. Some languages have keywords, so we could actually put final on here, and now it's not allowed.
Great.
Yes.
So I love this language. It's great, but I sometimes like to be able to write notes to myself in my language. So we're going to make a comment. So what we want to do is create a little comment thing here. So we're going to define a new token for the comment. And here's the one more audience participation point. What should the initial character of our comment be?
Happy face.
Not happy face. I heard slash. Semicolon. Semicolon. We'll go with semicolon.
Not semicolon.
Not semicolon?
How about slash?
Oh, okay, slash. Do slash. Great. So we're going to do slash, and we're going to say anything that is not carriage return or line feed. You can have any number of those non-carriage return line feed comments, and then there it is. So please give that a classification of comment. And now what we want to do is, we don't care about comments. We want to add it to the list of ignorable things. So we're going to add it down at the bottom.
So the tokens we hate?
Tokens we hate. We hate comments. Well, we kind of like them. And now let's go add a comment. And so if we type, we see we get comments. Fabulous. Ooh. It's a repeat, though. This is sympathy applause. That's sad. No more of that. Leave me hanging if you need to leave me hanging. I don't want to feel a sense of obligation.
I don't mind, Chris.
Oh, you don't mind, Gio? Okay. Great. So you've seen comment.
We're good.
Yes. Back to more slides. Classification. The question was, is the classification ignored in the language, or is it just for colorization? The classification. Oh, go ahead.
It's not used in the actual parsing. It's only for the language services.
Yeah. Can you switch to
Yes,
slides?
I'm sorry.
They can't see.
Sorry.
So we saw attributes, which allows us to annotate our grammar with additional information. Some of them are consumed by the parser, which is things like the case sensitivity. We other things like the tokenization or the classification is consumed by other runtimes. The values of, which is one of the operators in the language, which lets you do this unrolling of the lists. And then we have parameterized rules, which are probably one of the most powerful things in the language in terms of being able to build very compact, reusable grammars. You'll notice the pattern. Very few slides, lots of demo. We were trying to keep that going. So the number one question, while being in the booth, while talking to people, the number one question they say is, that IntelliPad experience is awesome. I love it. But what am I going to do with it? How do I make it work? So, okay. So let's take our beautiful contact grammar, and we're actually going to make it do things. So let's go back to our demo. And we can imagine lots of ways you want to use this thing. Maybe you want to use it from a command line. Maybe you want to integrate it into a .NET program. Maybe you want to go use it on a website. Maybe you want to use it in a presentation. We don't know. But let's walk through how we're going to use it from a command line. So what Gio's done here.
Here's our file.
Yeah, so we're in the Oslo SDK directory. We've gone to the bin directory, and we've copied those two files we just wrote into that directory so that we don't have to do a lot of long paths and munging with it. But this is just the standard Oslo SDK that you can download off of the Oslo Dev Center.
Yes.
So we're going to run the grammar compiler, mg.exe, not to be confused with m.exe, which is the schema compiler. Eventually, we hope to integrate them and have one beautiful tool that just compiles the universe. But for now, we have two. Nascent. So Gio compiled it. We got an MGX file. An MGX file is a compiled grammar. Gio, what is that compiled grammar format?
OPC format.
It's an OPC format. The OPC is the Open Packaging Conventions. It's what Word Doc X files are, XLS X files are. And it really is just a zip plus XML. So Gio, please open it. You can see we have two files in there. We have the content types for part of OPC. And then we have a XAML document, which is the definition of your parser.
With tokens I hate in there.
So the grammar stays.
I'm easily pleased.
Yes, Don, you could have just written that XAML instead. If you like XML, you can write that XAML. And for you, you can no longer use the nice syntax. Great. So we compiled it. Now let's go use it. So we're going to run mgx for execute. And it is going to take the compiled grammar as an input and the instance document, that input file we wrote, and we're going to run it. And it's going to output an M file, an M scheme, an M graph. We can now take this, and we could put it in the database. Kinda.
Yeah.
We wrote a bad grammar, so this wouldn't go very well into the database, but
Yes.
that's the point.
We have other formats too, Chris.
Yeah, we also have
XAML.
XAML. We love XAML. We can output XAML as well using the /t option, I think.
Yes.
And we can get XAML. So, Don, you can get back into your XAML. You can stay away from that nice mgraph syntax. You can get all the way into XAML. So that's compiling for the command line. Pause for a moment. Next step.
He was waiting for an applause.
No, I wasn't waiting for applause. I wanted people to absorb. There was so much information in that.
Okay.
Those two command lines had depth.
Okay. Yes.
Now, let's go consume this from .NET. So we've seen how to do it from command line. You could imagine integrating that into a build process. You could write a script over the top. You could do whatever you want to do. So let's start at Visual Studio. We're going to start an empty new project. None of this pre-canned project BS. We're going to start with a vanilla project. People who start with those things just, oh, they're horrible. Great. So we have an empty project. We need to add a couple references. There are 2 DLLs, I believe, that we need to add.
Indeed.
They're both included in the Oslo SDK. They are
Microsoft mGrammar and system.dataflow.
Yes. Now we have all the bits we need.
We need to add the file.
We're going to add the grammar. We're going to add the grammar in here. We're going to want to use the MS build task. Now, instead of running the command line and adding a reference to the compiled file, we want to compile it dynamically every time you hit build. So, okay, I need to ask a favor, everybody.
Nascent.
Nathan, I'd like everybody to stare at your feet for a brief moment. Stare at your feet. Gio's going to do some very bad things to Visual Studio. There's a prize on the floor. If you look under your seat. No, so what we have to do here is we need to add a reference to the MG build task and then set that we want that grammar file to be compiled using that task. The good news is there is a sample in the SDK that Michael Weinhardt wrote. That's
called Song.
Called Songs.
Sorry.
And it has a project that you can go copy and use instead of having to try to figure this out yourself.
That's what most developers usually do.
Yeah.
Copy projects.
Copy projects. I'd never try to create anything new. Great. So we're up and running, right?
Let's build it.
Great. We can build. We have no errors.
It built.
It built. Yes. Great. That was it. That was just a. We didn't screw up the demo part.
We're just very happy about
there was
that.
no applause needed there. Great. So now what we want to do is we want to go consume that grammar. While writing this talk, we found a bug in one of our APIs, so we have a new version of that API that we're going to post to our blogs. You put it outside the class definition, which won't work.
It's a DSL I'm not sure familiar with.
Yeah, this is a crazy DSL here. And so all this is doing is it's loading that MGX, that compiled image, from the resources, from the manifest, from the compiled assembly.
The build task use the MG tool to compile an MGX and put the MGX into the assembly.
Great.
So we're just getting we're just loading a stream from the assembly and loading it with the mGrammar compiler.
Lovely. Let's parse that file.
Well, let's load it first.
Yes. Don, may I borrow your watch, Don? I don't want these people to be held over. I don't want them to be in trouble with the next session. And I don't have a timekeeping device of my own. This is really nice. Do I have to return it? Great. So we've loaded the parser. We now have an instance of the dynamic parser, which is the one we loaded from the file. We just loaded that data up into memory. We populated some structures. And now we're going to go parse string literal. We're just going to create this. Did you add all the references for all the types that you need, like string reader?
Oh, yes. You are so good at this demo features in Visual Studio.
Yes. So we need to wait. There are 6 extremely important characters on the screen right now.
Any guesses?
Any guesses? Not from my team? Object, great, yes. Okay, I just had to wait for it to percolate far enough over. Object. You do not get back a strongly typed OM. You're getting back structured data. We did not want the OM to make a commitment to a specific rep in memory. The idea is you may want to cons up your own ASTs. You may want to cons up, just CLR classes on the fly. You may want to create your own DOM. You may want to create XML. You may want to do any of these things. And so we didn't want the API to take a dependency on that. Instead, what we have is an API called iGraphBuilder, which is for mgraphs. And it has a few methods on it to allow you to either walk data that conforms to mgraph or produce data that conforms to mgraph. Now, we are psychic, and we know that the default graph builder is called
GraphBuilder.
GraphBuilder. Yeah. So it's not too hard to figure out the pattern. And we're going to new that up, and now we're going to walk our OM that we got back.
Great.
So all we're gonna do is we're gonna walk this thing. We're gonna look at. You remember the structure we had? We had main, we had contacts, and then we had a contact, and then we had an alias inside the contact, and we had the name. So we're gonna go dump the names out to the console. So we're gonna walk the top level nodes because we know that we have a couple contacts under there. We're gonna go to each contact. We're gonna walk its graph structure, and we're gonna look for the one called alias. We're using identifier, which is a type that's included in system data flow, and it's just like xname. Just think xname. It atomizes a string and allows it to do very efficient comparisons. Scroll.
Oh, sorry.
Thank you. Interactive audience, love it. We're going to look for alias. We're going to find the one called alias, and then we're going to console write line the singular value that's included inside of that. I have a question up front.
Chris, do you still have the IntelliPad? I'd love to see what the data looked like so I can.
Excellent, Don. You have great suggestions. It's fabulous. We'll let Gio finish real quick, and then can you pop back to IntelliPad?
Yes, if
I hope you had kept it running. Excellent. So if you look on the right, you can see contacts. Under it was a contact, and inside of there was an item called an alias, and then inside of that was the name GODL. So we're just going to walk that structured data using a simple DOM, simple reader API, and print out the results. So if we run, excellent.
Oh, wait a minute, hold on. I had a.
Did we have?
We're so fancy that our labels can be objects.
Oh yes, that's so fancy. You mean we forgot what we should type?
Yes. I was covering.
That was good. Good recovery. Good recovery. No one noticed. Don't worry. Okay, and run. Did it print? Did it print?
There we go.
Wonderful. So let's pop back to the slides really quick. From the command line, we saw mg to compile a grammar, mgx to run the grammar. You can see that we took the M file, created a zip file called mgx. We took the zip file plus an instance document. We created some XML or some M or whatever you wanted. In the CLR, there was a build task, which is the exact equivalent of mg.exe. There was another thing which we did not show you, which is mgrammar compiler.
Well, that was in that snippet of code.
It was in the snippet of code. There was in there somewhere. There was an mgrammar compiler. And that's the in-memory version of the compiler. You can actually just instance up the compiler, run it through, get out the data, and parse on any dynamic grammar. That's exactly how IntelliPad does it, where you can type in a grammar dynamic on the fly. We saw dynamic parser, which takes that compiled grammar and an input and gives you the output, that structured data. And then the graph builder, which is our OM for walking that structured data. Great. I am tired of this silly contact language. I fear that you guys will walk out of here going, well, I don't need to write a contact language. So we wanted to come up with something a little more real. And so, Gio, if you could switch over. What we did is Gio had a plane flight back from Miami.
Yep.
And decided to write grammar for writing setup programs. How many people have written an MSI? Do you love that process? Great. How many people use Wix? Excellent.
It's a great technology.
Yeah, it's fabulous. So MSI was so complex, so hard to work with, that we created an XML DSL on top of it to generate the MSI. And what we're now finding is that XML is so complex and hard to work with, we need to create something to generate it. So what Gio did was he wrote a little grammar here. And so you can see we have a product at the top, and we have some IDs, some fields, and it's somewhat understandable. I think that, how many people can guess what this is going to do? Anyone? Ooh, that's, okay, we need to work on our grammar. It's not quite up to snuff. Okay. But one of the nice things about this is it looks like free-form text, it looks like property value pair, but it's actually very strongly typed. We have a strict grammar for this, so if you make a change to the text, like remove that, you'll see we actually get a squiggly. We're validating syntactically, yes, that the tokens conform to the data types. We're not doing a full type system. We didn't write a runtime that's doing that level, but we can validate that the names are right.
So here's the grammar, Chris, and if you see, we had a very nice parameterized property here called property, and it took a name equals a value. And here's the ID feature. This actually lets us label something with a variable. So ID of n is the variable here. And as you can see here, all the product properties were simply property of ID with some syntactic strong typing.
That's nice. So let's go back and look at the grammar.
Do you want to add one?
Oh, yeah. Let's add one. What field should we add to our setup program? Copyright. Copyright. We'll put a copyright. This is a man who likes to make money from software. I can tell. So we're going to add copyright. And
String?
String. Yes, it should be a string. Great. And now we can go back to our grammar. And we can see that when we start to type, initially, wait, stop. Oh, go back. We can see we get a red squiggly because copy, or however far you got in the word, isn't a valid name. But once he finishes typing, it'll finish. And now we can write the string. And if you just wrote a number there, you'd again get the error. You would hope you'd have gotten the error, but we'll ignore the fact that you didn't get an error.
Oh, well, wait a minute. No, I wanted to have single words be allowed to be strings.
Ah, okay.
And dots.
You with your silly...
But if I did a space, then it would break.
Okay, great. So let's put it back to a string.
And look, I can do this here.
Great. So, Gio, can you run the tool? Does this thing work?
Yes.
Is this all smoke and mirrors? Is there any truth? Are we lying? He's going to run this tool. So
Let me delete my practice runs.
Oh, good. What Gio did is he wrote a backend for this that takes that grammar.
Well, the team had a simple OM on top of Wix that I called up.
Yeah, so you concept these objects in memory, generated them, and spit them out. Using the graph builder OM that we saw, able to walk the data structures. And so you ran it, and could you copy that file, make it be in .xml, and I want to see it in the browser.
Am I getting the names right? No, I'm not.
This is the part where it would have been better to put that in an easy directory.
Yes, I know. It was one plane flight, Chris.
It was one plane flight, yes. And literally, that was all you spent on it. Great, we've got the file. Let's open it up in XML.
Well, let's rename it. That's the old one. And let's get rid of this annoying little thing in the top.
Not our fault. That was some other team. So let's look at the XML here. First off, I mean, XML's not horrible. It's not horrific. I can kind of get it. I mean, Wix did a very, very reasonable job wrapping the OM that they had. But the thing that you should really notice is the Wix, or at least I think the Wix, it's hard to see any difference in the language. You don't see keywords. You don't see the difference between properties and values. It's
gray the syntax color. All the syntax coloring is based on the XML schema, not on our schema.
Yeah, it's basically the XML is more important than my domain in the XML model. So letting the peaks and valleys of the language pop is really what we think we get out of the DSL approach. Does it install?
Oh, yes.
Can we install? Is it possible? Great. So slides?
Oh, no, it's got to be there.
You're making sure that it wasn't just a screenshot that showed up. Great. It installed. So we had this Wix simple language. It's about 50 lines of M grammar, about 400 lines for the backend that did all the rest of the work. So pretty maintainable thing. And then we just used the rest of the standard Wix chain to generate the MSI. This is a much more concrete example of if you were building lots of programs, if you had people who were going to write a lot of setups, you'd probably want something a little easier than a big XML file to edit. So, mgrammar is a way to build these textual DSLs, a way to write structured data in a format that is the shape you want it to be in. It allows you to do the validation. We have declarative language services. You can integrate this into the tool. You can, there's this dream. So Steve Luco, when he originally started this work, had this idea that we would eventually get to the place where languages were like components. That you could take a language and derive from it. You could combine languages together. You could build a common infrastructure for them. And there's a lot of power to being able to do that, to being able to reuse this. There's also a lot of potential for horrible, horrible misuse. I'm reminded.
More than likely.
Oh, it's going to be. we're really changing the economics of building new languages. We're trying to make it much more approachable, bring a lot more people into the fold, let them be able to build these things. But with that great power, they're going to just do horrible, malicious things to the universe. I mean, I think back to when, the first, lots of fonts in a system like on the Mac came out, and suddenly everything was a ransom note. It was terrible. And so we really could get to that point where there's like, you go to write a library and you have to talk to 40 different languages. But I don't care for now. For now, we're still building this. We're still trying to figure out what we're going to do. We really want to, get a lot of people out there building it, playing with it. So now is the time to do evil things. Build your language, unleash it on the world, and then we're going to figure out together the right structure to have, how to have families of languages, how to reasonably extend them, all those things, have design guidelines. We're going to figure those out. But for now, let's be bad. It'll be fun. So download the CTP, go build a language, and most importantly, send us feedback. I told you that this feature, this product was not present 6 months ago. We built this because you guys told us that we should have this, that this was something you wanted to be able to write. And so we're actively looking for feedback. Gio's checking in new features, I think, right now. He's trying to razz in to submit a change.
I'm trying to get a certain grammar done if asked for.
Great. And so please send us feedback. I guarantee you we'll read it. We will respond to it. It may take a little bit of time. But either send Gio mail at GODL or me at Chris Ann, and we'll give you a response. We'll figure out what it is. So are you going to get a magic grammar?
Well, I'm keep looking for it. So if people stay around,
you're going to look for it. So at this point, I'd like to open up for questions. There's mics in the corners. Is there a public forum on that? Yes, it is. On the Oslo. If you go click that link on the PowerPoint, it'll navigate you right there. So, great. Question over here?
That graph builder stuff looked kind of ugly. Couldn't you use the new dynamic language features to get rid of that ugliness and just be able to dot through that stuff?
Yes, we would love to be able to use those. Right now, we've been trying to not have a single monolithic dependency chain where nothing would work if they weren't all present, and so we have not yet started to build this on top of .NET 4.0 and the C# 4.0 features. And so right now, we just are using vanilla 3.5.
But by the time of RTM, would I expect that to
I would love to see that. It's a great thing. I'd love to see it. Over here.
So now we can go from text to graph in a nice declarative way, but from graph to text again, like doing code generation.
It's been the #1 feature request of the conference, so we're actively looking at doing it.
Yeah, okay. We've actually all been harassing Gio about this feature for ever since we started working on this, and he's like, no, we'll get to it. And so thank you for asking again, because now publicly we will shame him into writing that code. Over here.
Slide or two back, or on that last one with the Wix, it was the hooking stuff up bits. Are there some resources around hooking this up?
Hooking it up to the language side or to the runtime side?
To the runtime, to both.
So the song sample that's included in the SDK does it have a backend to it? Yeah. Yes.
It does a simple backend.
So the song has a backend, so it shows you how to parse the tree, how to integrate it, how to make all that stuff work. So it's a full sample that'll do all that.
Okay.
So,
thanks.
Great. Over here.
Chris, Gio, I look at the rules for defining tokens, and I see a lot of familiar yet slightly different things like how to define ranges, things like clean cardinality operators, alternation, negation. And so my question to you is,
say it.
do you think you're too good for regular expressions, or did they say something unfortunate about your mother at a dinner party?
Gio, I'll let you take this one.
We have heard that request as well, too. We try to approach to make the language uniform across syntax and token as much as possible. But that said, we want to hear the feedback to see whether people really want it to be exactly regex.
Yeah, it turns out that we have an M grammar for M grammar. And so the whole thing is, of course, built recursively on itself, all that stuff. And so we'll make you a version that does it.
Then rewrite that version in regex.
Yeah, we'll rewrite that. Yeah, it'll be great. No, we're looking at it. That's great feedback, though. Cool. So thanks. Over here.
So you actually answered my question.
Great. Okay. Over here. No, sorry. Go ahead. Go ahead.
Can we download the M grammar for M grammar?
Yes.
It's in the SDK.
It is.
The files and the M schema grammar too.
Cool. Thanks.
And well, I missed one point
Yes.
that I should have said.
Yes.
Notice the third line of text up here. We're releasing this whole language under OSP, which means that anyone can go implement the specification. We're going to publish the specification. We're going to let other people implement them. We hope to have 1,000 people writing backends for this. So, over here, question?
Quick question. Is it Turing complete?
Is it Turing complete?
Turing complete. The parser is context-free. So actually, we tried to avoid talking about the parser itself because we want to make this very general purpose. But I know a bunch of people want to know. It is a generalized LR parser. It is LALR1. We do have precedence keywords in the language to help disambiguate precedences for expression-style grammars and for if-then-else. I mean, dangling else problem. And we have a disambiguate interface you can plug in the back end if you want to resolve your own ambiguities. So in that perspective, you might try to say you're Turing complete, but the grammar is context-free.
All right. Thanks.
And just for fun, while we were playing around with this, Gio previously has written a C# grammar, VB grammar. We have a lull code grammar. We have a bunch of these things.
I'm trying to find the lull code grammar.
Oh, great. We'll see if we find it in time.
I think the last gentleman covered my questions pretty well, but I'm curious about what the most challenging aspect of this project has been for you.
For me, it's been ambiguities in precedence. I mean, that's the thing that trips people up traditionally in grammar languages. And what we're trying to make it as easy as possible for you to get nice default behavior from the language, and yet still have the complexity to manage it, right? Because if you need to do it, if you need to fine-tune the ambiguity performance, then you can put the keywords in. That I would feel is the hardest part about the actual grammar language.
Yeah. Great. Thank you very much.
Thanks.
Hi. Do you plan on allowing editing the grammar within Visual Studio?
Absolutely.
Oh, yes.
Absolutely.
Yes.
Everything you saw there is going to be supported in Visual Studio.
Yes.
Okay.
Over here.
Was this all going to tie into the code generators for VB and C# so we can use stuff other than T4 for?
That's a good question.
We've got a lot of questions about T4.
Yeah, we've got a lot of questions about T4. I think that what I hope we do is what we talked about before, where we actually can take the grammars and then go the other way and generate the text from. So I hope we can get it down that space. But yeah, we'll figure it out. It's great feedback, though. I mean, it's something that we really want. We've heard a lot of people asking they just want to generate the source code out of the back end. So, over here.
So I agree with the first gentleman talking about the graph builder is pretty hairy. It also feels pretty old school. So, but besides going dynamic and
old school, yo.
Yeah. What about link to mgraph?
That's such a It's a good idea. I like that. Yeah, if we do dynamic, we probably will get it for free. But no, that's great. Yeah. By the way, the graph builder interface, just to give you context, we said a lot of this stuff came in late. The graph builder, we checked in that OM a week before we snapped the PDC build or something like that. It came in really late, and in fact, we had to backpatch it on some of the stuff. So if you go look around at where graph builder touches the
it's
M
very
grammar,
kludgy.
There's some very kludgy. Like there's actually a static global variable that we use for which the builder is. So it's horrible stuff.
I have the change on my machine.
I know it's good. Yes. But so the graph builder is definitely one of those areas that came in a little tough, and we got to fix it. So over here.
How does error recovery work in your parser?
Ooh.
Oh, great.
Ooh.
So we do have
Is Andy Ball in the room? No.
We do have a very traditional, from the Dragon book, we have very traditional error token-based error recovery in the grammar.
So you're dropping tokens until you find a resynchronization point of some kind?
Yes, but we had an intern this summer who was a great intern, who, if he was in the audience, I'd push to accept his offer if he's watching this live cast. He did Burke Fisher-based error recovery for us, so we have trial-based error recovery going where you will not need to do error tokens.
Okay.
And that's actually turned on in our current bits in the IntelliPad 3 pane mode. So you could.
How do the errors get manifested in the output of the parser?
So we do have an error reporter that we report errors to, we are looking at when the parser does work in incremental mode, so you can actually get a checkpoint for the language service style thing. One of the things I do want to say about language services, by the way, is we want to keep training as many grammar attributes as possible to make language services easy. So we have in the M schema, which was further along, we do have formatting in there and several other language service features. The farther you go into language services like statement completion, it gets very tricky to do just from an attribute. But we try to want to make it as easy as possible. Jeff Schlimmer here, who is on the team, worked a lot on using error token style things to do statement completion. And in that sense, tried to create nodes based on errors that had partial information in them that he could then use to do the semantic analysis and so forth. So we're heavily investigating all of these things. Did that answer your question?
Yeah, that's good.
Okay, I'm sorry, I stacked Oben there.
No, we can get into more details later.
Oh, over here.
Yes, come by the booth.
Over here.
So for those in our organization who are less textually comfortable, are there any plans to allow for nice, pretty graphical creation of grammar files, like in Quadrant?
Well, so one thing, if you saw Kenny Wolf's talk on double workflow, he had a prototype workflow language. And in that demo, he took that file, compiled it to XAML, popped up XAML, and was able to see in Visual Studio the live visual version of the same DSL. And if we do the source generation work, then we might be able to go two-way at that point. So that would be my dream.
Thank you.
Great. Over here.
So have we reached the high point for XML, for example, in...
or the low point.
Whichever way you look at it. Do you see this beginning to take over? I mean, XAML, for example, is getting so incredibly complicated for Silverlight or WPF or et cetera. So do you see this beginning to replace or at least be an alternate way of expressing those elements inside of those other technologies?
I hope so. Okay. That's our dream. I mean, so yeah. If no one ever has to write if no human has to write an angle bracket again, I'll be happy. Except for less than or greater than. They can still do those. Over here.
So I was just curious, are there going to be other modes supported besides just dumping things out to a file, like for example, streaming or two-way tools and round tripping and things like that?
I hope so. You should write one.
Is that in the plans for 1.0, I guess?
No, in 1.0 we'll definitely have the dumping one. Whether or not we support a streaming mode on it, I don't know. The API set, we're going to do a lot of cleaning on that. We haven't even begun to touch the API of what we have in the framework in terms of getting polish around that. So the actually suggestions as to which tool set you would want to see in the bits actually be really appreciated, because what we do with most of it is we write the M schema compiler, and then we do stuff like the IntelliSense mode and things like that. And so we do a lot of hitting it on the CLR side. And so where people want to use it in a stream processing model will be super interesting to hear. So,
okay, thank you.
Thanks. Over here.
For the token matching, are there going to be built-in types? So instead of saying 0.9, I could say give me an integer or something that's a string.
We have a very small base standard library that you could actually go get some of those things from. We would definitely have a lot more work planned on beefing that up. So we haven't really shown that too much. We call it unsupported. But we definitely want to build up a standard library so you can do a lot of these things. We're also looking at definitely doing Unicode categories. I mean, everything we showed you was very ASCII-based. We do want to have Unicode category support in the lecture intrinsically. So,
great. Over here.
Any plans to be able to nest languages together in one file?
Yes, that's already in the bits. There's a feature already for nesting and for allowing you to do that. Right now it does, well, actually, why don't you explain what it does now?
Oh, well, you can, those language constructs you define, you can reference any language. You can reference a syntax from another language into your language. And a language doesn't have to have a syntax main. So you could have a packaged language that just has things in it, and then you can reference it from other languages.
But in the instance document, like I create a...
Yes.
Okay. Right.
Yes. Yeah. Now, the dream is to be able to nest a full language inside another language and manage the lexical differences between them, et cetera. So we're trying to get there. Okay. But we can definitely reuse syntaxes from other languages and tokens from other languages.
Thank you.
Can I extend the three-window look to N windows, add more parts in?
So great question. IntelliPad is a very simple environment that everything's right now is generally Python scripts and XAML files. So you can actually do anything you want with it. So you can go create a mode that does whatever you want. You can create a new language mode. You can set it. You can write whatever. So it's very flexible in terms of that stuff. We like to think of it as very Emacs-ish.
This may be related to that, but in your vision of the tooling support, would that include being able to pipeline grammars, where the output of one grammar is automatically fed into as input into the other grammars?
That's a good idea. I like that too. Yes, I mean, in some ways we're doing that right now in our tool chain, because we actually take M schema and we compile it in and we send it down into XAML that we then compile into SQL that we can do that sort of thing. But having a generalized mechanism for it would be great as well. So
Are you familiar with OMEDA and the work that's being done there?
Are you?
No, not yet.
I'm not. I would love to hear more about it. That would be great.
Okay.
Excellent. No more questions. So thank you very much for spending lunch with me. And Gio?